All right. So today is going to focus on, like I said, going the opposite direction from what we did yesterday. So we're going to do writing parametric equations. Okay, so the idea is you're going to be given a rectangular equation, and you're going to be asked to write parametric equations. But the key to this is you can't do that unless I give you something about the parametric equations first. So for all of our examples that we're going to be doing today, we're going to be given our rectangular equation, which is y equals 1 minus x squared. This is our rectangular equation. Use it, and the piece of the parametric equation to write the other parametric equation. So the directions are a little strange, but essentially, I want you to use this equation, y equals 1 minus x squared, for all of the examples that we're going to do here. Okay, so we're going to use that equation, and then we're going to be given one part of our parametric equation. So either what x is or what y is. And then we have to write the missing piece. All right, so what that's going to look like is this. I'm going to give you, for example, x equals t. Okay, so let x equal t. We need to find the y equals part of the parametric equations. So we know what x is, but we need to know what y is also, because all parametric equations have to be in a pair. It has to be one of them that says x equals something with t in it and y equals something with t in it. So we've got to find both parts. So I have, and I'm just going to write this so we can see it. I have my rectangular equation, y equals 1 minus x squared. I have the x equals part of my parametric equations, and that's what my goal is. My goal is to write a set of parametric equations here. Okay, I've got the x equals part. The only piece that I'm missing is what y is. So this one's a little bit easier in that we have x is equal to t. So basically, in my rectangular equation, I can replace x with t. And that's what I'll do. So let's replace x with t. And that's going to give us the second part of our parametric equation. So I'll have y equals, instead of 1 minus x squared, it'll be 1 minus t squared. And that is our parametric equation set. Like, we have to have both parts. We have an x equals part, we have a y equals part. We've got both pieces. We're good to go. That's our goal, to be able to come up with the parametric equations. Like I said, we're going to do the graphs on Desmos here in just a minute, so we won't graph these by hand. You've had enough practice in the first two assignments for this to actually graph by hand. I don't want to do that again today. I'd like to kind of show you how you can use Desmos for this. Okay, so let's try another one. So we're going to use the same rectangular equation, y equals 1 minus x squared. But this time, let's let x equal 1 minus t. So then again, we need to find the y equals part of the parametric equations. Okay, so just like before, I'm going to kind of gather my thoughts, make sure I have all the pieces in the right places. I've got my rectangular equation is still just y equals 1 minus x squared. This time I'm given that the x equals part of my parametric equations is 1 minus t. I need to figure out what y is to get my parametric equations. So just like the last time, I look at what I'm given and I do a substitution. So I know what y is, right? Y is just 1 minus t. I'm sorry, x is 1 minus t. I'm going to just replace x with 1 minus t in my rectangular equation. So just like we did in the previous example, we're going to replace x with 1 minus t. And that's going to give us the other piece of the parametric equation. So we'll have y equals, actually, let me write that here first. Y equals 1 minus, and then 1 minus t squared. Now, I don't mind how this is written. It is written in the form where it's y equals. So theoretically, we could leave this as is. I kind of like the thought that maybe it will simplify a little bit. So I'm going to work on that first. I'm going to think about how could I simplify this a little bit. The first thing I'll have to do is multiply 1 minus t times 1 minus t, because that's what 1 minus t squared means, right? So 1 minus t times 1 minus t is going to give me 1 minus t squared. If I multiply those out, I get 1 minus t plus t squared. And I think you guys can probably do this in a much quicker manner, but I just want to make sure we're clear where it's going to end up. So when I multiply 1 minus t times itself, I get 1 minus 2t plus t squared. So that's going to go back into my original equation here. So I'll have 1 minus what I just wrote, 1 minus 2t plus t squared. And then I've got to simplify that. So combining like terms, I have to subtract everything in the parentheses. So you can do this one of two ways. You can figure out what it looks like to subtract everything in the parentheses and then combine like terms, or you can do it all in one step. I don't care. Well, let's do it where I subtract everything in the parentheses. So all that really does is it just changes all the signs on every term in the parentheses. So instead of having, instead of having 1, you're going to have negative 1. Instead of having negative 2t, you're going to have positive 2t, and so on. And then just simplify that a little bit. So I get y equals, 1 minus 1 is just 0. So then we have 2t minus t squared. And that's what I'm going to write for the second part of my parametric equation. Now, like I said before, we went down this rabbit hole. If you left it in that original form, it's not wrong. I don't know that one way is any better than the other. I just want you to understand that there's a variety of ways that we could write that equation. So some of you may have stopped right here, and that's okay. Others may have gone a little bit further and simplified it. Whichever, I don't care either way. But that's our set of parametric equations. We have an x equals something with t in it, and we have a y equals something with t in it. If I wanted to graph that, I could either look at the rectangular equation, the rectangular graph, and figure out orientation using the parametric equations, or I could plug some numbers in for t and get my parametric graph that way. So far, we've had 2 examples where we were given something with x equals something with t. So for this third example, we're going to say, let y equal negative t squared. So this time, we're going to need to find the x equals part of the parametric equations. Okay, last time we were given the x equals part. Now we're going to be given the y equals part. We've got to find the x equals part. So just like before, I'm just kind of organizing my thoughts here. I've got my rectangular graph, y equals 1 minus x squared. I'm given part of my parametric set, y equals negative t squared, and I've got to figure out what the other part of that is so that I can write my parametric equations. Okay, so this time I'm given what y is. So we're still going to do a substitution, but instead of substituting what y is, instead of substituting what x is, I'm going to substitute what y is. So I'm going to replace y with negative t squared. So replace y with negative t squared. I'm again going to do that down here, and then we'll write our simplified version up with the x equals part, with the y equals part. So this one gets a little weird. When I do the initial substitution, I get negative t squared equals 1 minus x squared. Okay, that's weird. I need to solve this for x. At the very least, when I write my parametric equations, I have to have them solved for x and y. So I'm going to have to figure out how to solve this equation for x. Lots of ways you could do that. Maybe I add x squared to both sides, and there's other ways you could do this. I'll just show you one way, and you could do it the other way if you'd like. So we'd have x squared minus t squared equals 1. Then let me add t squared to both sides. So then we get x squared equals t squared plus 1. Now that's great, except I still have x squared. I need it to be x equals. So I'm going to have to take the square root. But there's something we have to be careful. When we take the square root of both sides when we're solving an equation, what do we have to include here? Plus or minus. Which means there's actually two equations that define what x is in our parametric equations. Okay, one of them by themselves does not do it. It has to be both. This one looks a little strange when we graph it. But let's go ahead and write that up here. So our x equals equation is x equals plus or minus the square root of t squared plus 1. You cannot simplify the square root of t squared plus 1. I know instinctively you think you can, but you can't. If you're ever unsure if something will actually simplify any further, a lot of times you can just look at the graphs of the two things. So, like if I looked at the graph of square root of t squared plus 1, and then looked at the graph of just t plus 1, or x squared plus 1, whatever, they're going to be very different. And that's kind of a really easy way to figure out if it'll simplify. So now we've got all our equations. We're going to graph these on Desmos.